So I'm going to talk a little bit about the tools for P management, and then we're going to have a short break, get recharged with coffee, and maybe there's other things down there, and come back for a couple of more talks that you'll see on the program. P Indices is here, and Dennis Frame, and then there's going to be a short session, another 20 minutes for panel discussion to try and get some discussion going back and forth here. So with that, I just want to talk today a little bit about the history of risk assessment, the tool that what a lot of us have been using for phosphorus management. How did that come about? What led to the revision of the 590? How that's gone, how that's occurring, and what has been involved with that. Some of the use and misuse maybe of these tools for P management, and looking at different BMPs and how they fit into this, and how these tools can be used to either identify, select BMPs, and the best way forward to this. So what we did about 15 years ago was decided that we needed to take some of this research out to farm fields and do it rather than bringing the soils back to the lab. And there was a network of research from land grant and ARS collaborating across the country, supported by ARS and NRCS, looking at these small plots. And basically what people were doing were raining on these at the same rate, so that our data was comparable across state lines, and that we could hope to get a larger database that was, we'd suffered a lot, we've done a lot of work, but we'd all tended to be fractured and doing it our own way in our own areas. And so this was a good example, I think, of coordination, but that each had their own focus and their own goals. But it did allow us to get some information, and what really we were able to do was standardize some of these techniques if you're trying to develop tools, and they're based on science, to give us some science to look at, to support that. Looking at how do you do these tests, and trying to get some consensus on the best way to get the right information to use to drive these tools. And we looked at being able to establish a relationship between soil phosphorus and what was in the runoff. We know that as the more there's in the soil, there's going to be more in runoff, but checking that relationship and getting some more quantification behind it and support that when we take these tools to farmers, that they can understand and say, okay, that makes some sense to me, therefore we're asking them to change. We need to provide the evidence that they can understand, and they're more likely to perhaps buy into that idea. And then how was that integrated and looking at incorporating, but rather into the more whole process of planning. But partly it was a success in terms of these tools were developed as a group effort, somewhat of a consensus, and it was somewhat flexible to states. Each states had their own policy goals that differed from one to another. And as you will see, that was a strength, but as we probably realise, it's also a weakness. And so what we did, this is some work in Pennsylvania. Each of these points is using that rainfall simulator, and you get a good relationship. These soils didn't have any fertilizer applied for quite a while. But we're looking at most of these soils, as you know, were probably based on nitrogen applications for manure, and so they were overplanted. But most of these soils were above the crop response level. But what it did show that we could split this into two separate lines and give us an idea that above this split line, and not everybody sees this, but generally there's an inflection point where that curve starts to get a bit steeper, and it kind of helps us define, okay, there's a level above which there is the potential for that phosphorus to be released and remobilized from that soil is greater than below it. And I guess it's somewhat, as a group of scientists batting around numbers, 200 was a number that was kind of come forward, but it did give us some ideas. Another way that we talked about was looking at, well, if you're having 1 ppm in point source, requirements, then you just go across here to 1 ppm to see where that comes on that soil test peak. But it did allow, from different states, using this technology to get some more science. And some work then that kind of followed on from that helped us in get this idea across. It was more than just soil phosphorus. If you look at how much phosphorus is in the soil on these plots here, there were strip crops, so there were different fertilizer manure treatments over the period of years, and obviously there was more phosphorus in the top of those soils than there was down at the bottom, partly because there's an ephemeral creek that runs here, and this area is wet. Farmers probably not going to get down there anyway, but if you are basing this concept of tools for phosphorus management on just soil phosphorus, you would probably say this is the worst case. This is all right, and up at the top you've got more phosphorus there, so let's be more restrictive. When those little grey areas are runoff plots, the runoff, and this is how much phosphorus had been applied to those plots because of applying it for nitrogen in those wheat, alfalfa, corn rotations. And when you looked at how much runoff, we found that there's a lot more runoff coming off at the bottom. And again, a lot of us understand that, but it gave us some evidence to show that there's some areas of the landscape have a greater propensity for runoff. And here there was little runoff at the surface because it was infiltrating. It was hitting a fragipan that we didn't realize was there. On the other side of the hill slope where the person taking the picture is standing, that fragipan isn't there, and you really don't get very much runoff at all, but from the surface they look identical. But when you look at the losses, if we look at how much is coming off, the risk is greater here than at the top. So again, it's simple, but it was the concept that we need to have this idea for tools of phosphorus management. If we're looking at managing phosphorus on a risk basis rather than an agronomic basis, we're looking at an agronomic tool for management. Obviously, we've got soil testing, and that's what we need to know. But I think what we've learned is if we're looking for risk assessment, that we need this idea of this transport and this, you have to have a mechanism for it to get, whether it's runoff or leaching in certain areas, but you have to have that mechanism. And therefore, the tools that we've then developed for the management really need to account for the transport as well. Now that's great from a research point of view, but as probably most of you who are researchers in here know, that opens a can of worms, so to speak, and makes it more complicated. We as researchers like to make things a little bit more complicated, but transport isn't easy to define, but we know we need to include it in these tools. But having said that, we need to try and consider, I guess, the regulator's point of view that these tools that we use for management that get into regulated management need to have some black and white and some confines, and so there has to be this give and take to a certain extent. But this general rule that most of the PE comes from a small proportion of the watershed tends to hold around the country. That small proportion could be in different places in a different watershed, or a different where you are in Wisconsin, Pennsylvania, Arkansas. It could be a different part of that watershed, but generally speaking, it tends to hold. And from that, I guess, we've got this idea that there's a few states that haven't gone with using this phosphorus indexing approach as a risk assessment for phosphorus, as a tool for phosphorus management, but the majority have. And I'll touch on a little bit about, where are we now? But these are the different, for those of you not familiar, these are some of the properties, but basically the index is just a USLE version of soil loss, and you just try and account for the best you can some of those processes, and obviously it's not just the best because we've done a lot of work, a lot of people have put a lot of effort into defining what these processes are how important runoff is in one location, erosion to the other factors, but it's basically in different areas of the country or different states what major processes capture that phosphorus transport for them to use as a tool. And so, going about testing, some work has been done with testing, but not a lot, and I will come and readdress that in a minute. But you go back to that nice slope where we don't have any. But when you do apply fertilizer, either be a triple super, beta, or manure, then they don't fall on the line. But when we change that idea from a soil phosphorus to an index, because we're accounting for the application, be it whether it's timing, rate, the method of application, where they've got it, they tend to, because it enters into that equation or that tool of management, that we get a better estimate of the loss of phosphorus, and this is on a loss basis. And so then the science tends to leave then, and we have this social or political input into it as to where these categories go, and I guess we're still debating that. And I think, you know, we're obviously some of the standoff that we don't want to. It's that difficult because to decide where this 100 point is and setting your boundaries depends probably on the watershed you're in and the sensitivity of that lake. Not all of them are going to be the same, and therefore there is a lot of discussion as to where those categories should fall. But it does lead us to this idea that there's different parts of the watershed that are at greater risk for loss of phosphorus than others. And so our tools of management are really focused on trying to identify, with limited resources, where those resources will be best put. And this is just a simplistic idea that on the outer bounds of this watershed, we have a lot of infiltration. Runoff does occur, but it never gets to the stream. Therefore, they're at risk and might go to another field where that risk should be a bit lower. And then we have some intermediate areas, and this brings up another issue. We have intermediate areas, and we've got to decide what that risk we're allowable. A lot of what we did with the simulators worked at a 10-year return period storm. If we go increase that risk, say to a 100-year storm, you know, we try and explain to farmers what, you know, the logic behind a 100-year storm. When we had 300-year storms in our area last year, it doesn't really make sense. But if we look at, say, we're going to manage for that huge event that we know is going to carry 80% of our nutrients out in that one event, it takes this area of risk further and further out away from the stream. And so again, that's something else we've got to probably address and consensus on as to what risk are we trying to manage for. The small events that carry, you know, we might get 10 or 20 a year, or that big gully washer, toad strangler they call them in Arkansas. So where did the breakdown? That's all nice, but where did the breakdown? Because there was a lot of disparity across the country in indexes, and they varied with soils topography, and that's what they should have done. But we got a lot of criticism. We started to get criticism over the last few years that, you know, we were phosphorus researchers, developing our own tool, managing our own tool. It was a bit like the fox at the chicken house, so to speak. But the basic line problem was, I think in the Chesapeake Bay, they weren't seeing declines in soil test P, nor were there in some cases seeing the decline in P management or P application on soils that really shouldn't have been applying phosphorus to. The index wasn't sensitive enough to reduce that. And so there's a perception out there that some of these are farmer friendly. But I guess what we're now realizing, we always knew, but I guess system takes time to respond, and we've got to get a better idea of what is we seeing from current management and what are we seeing in terms of losses from the past management the last 10 years, so to speak. But I guess that one thing that we always try to get a point across, it's fine to criticize the index because it isn't perfect, or that tool of management, so to speak. But it never was meant to be the solution. It was meant to be a band-aid to manage phosphorus on a farm to minimize risk. It wasn't going to be to solve this phosphorus problem per se. And so that was I think we all tended to, as researchers, develop it. If we've done a good job, we go off, we do something else, and we go along. But Deanna Osman did a study in 2006 and repeated it basically in 2012 of the southern US. And we don't really need to get into which is more restricted than the other, but the idea here is what she did was used each of the index from these different states and then came up with, under same conditions. Again, it's not going to be perfect world because those same conditions vary from state to state, but what it shows is there's a lot of variability across state lines. And again, we don't need to worry about which state was which, but there were some states that never really said you ever got into a high category. There were some that were always in the high category, but there were some that never got you out of you're okay with N-based applications. And NRCS and EPA saw that and said that's just not right, and it isn't right. And so that really fueled this idea for the revision. And so then we decided, okay, we need to revise it. We do have some field data, but when we start to look at getting the field information to calibrate or to assess that index, we try to not use validate because we don't feel like it's per se a model. But one approach that we're probably going to have to use is use of models. APEX, Apple, TBET, they're all different acronyms that some of you are probably familiar with. Peter Vargas is going to talk, I'm sure, about Apple after the break. But they're all excellent tools that, if properly locally calibrated, might provide us with some evidence to calibrate against that index. Again, the problem is, we've got to make sure that these models are appropriate and are modeling the losses from where you are, and that because they both agree, they could be both wrong and they could still agree. And so one of the tools, I think John Laurie's here, he's spearheading an effort that a lot of these models are now very readily available. What if somebody picks one off the shelf and starts using it without much calibration? How much calibration is used? Because we really realize a lot of states, some states have more resources and effort and energy of the people in there to revise and assess these indices than others. And so what happens if you're using a non-calibrated model? And so part of the effort that's going to be going on over the next couple of years is going to be looking at that. And I think another key is going to be, at some stage, we've got to define, or come to some agreement to define either the conditions, rather than the amount, or those conditions that lead to an unacceptable loss of phosphorus. We've got to set those bars or those limits, otherwise we're just still talking about the general nuts and bolts. I'll just quickly go through these just some of the different BMPs that might be used from these tools. Quickly, our FarmGate basically are what we think of as solutions, because you're bringing less phosphorus onto the farm. Once it gets on there, and source management and transport are basically band-aids, but if we can minimize what's coming on, either with treating the manure, phytase, or solid liquid separation. Struvite is now coming to more the front, especially in Europe, of extracting that phosphorus back out of the manure in a more concentrated forms. We heard yesterday about, and I know IP&I and others have been promoting the 4 R's and stewardship, which is common sense basically. A lot of states now, we require soil testing, but we also require manure testing. And also now, because fertilizer has gone up, manure is a bit more of a commodity, it's moving around, so farmers are buying it based on their nutrient content. And so we do require, at least in our state, a nutrient content in that manure before it's land applied. And we base also that on soluble phosphorus in the manure, because they're not all the same, and that has a greater potential for loss in runoff. And so we gear our applications to the soluble. But getting that into the soil, again, credits, that builds up the idea that there are several BMPs that we know are out there that these tools for management should address and consider. And so we come up with this, these numbers of reduction credit that we've used in several indices. And again, it depends on state consensus, but we assign a percentage. These tend to be fairly conservative in number, but we can come up with some. NRCS have tried to do this by best judgment. The Chesapeake Bay have done probably a more concerted effort at trying to put some science behind these numbers, but it can be done. I'm going to pass through that. But I want to just kind of end with this cautionary tale that some of you may be familiar with, and it follows on from what Al was saying in the Lake Erie. Great improvements, and then there's been some more recent declines, and what was done in the 70s, new geometric planning and tools, these tools we talked about, probably one was soil fertility, soil testing, led to a great reduction in fertilizer application, and it also led to a great reduction in manure applications. And so what that translated to from these watersheds that Dave Baker and Peter Richards at Heidelberg have been monitoring and published was a decrease, and things started to improve. And the same with dissolved phosphorus. But what has happened over the last few years is it started to creep back up again. And we kind of heard it yesterday that although they might reduce the total losses, what's coming off tends to be more soluble. We might have 50% lower total loss, but it may be 90% of that might be soluble. And so that tends to be immediately available, and therefore the problem's not going away. And so really what has happened here was that when John Deere came out with their no-till, green-till planter, a lot of farmers went to no-till, and you went from a situation back in the 80s to very little no-till to everybody, to the majority of farmers using no-till. And what we again have learned is the management changed, but the tools for P management didn't really change with it. Our recommendations for fertilizer and manure management and tillage, I think, remained the same from conventional as they did as we transition into conservation. And we know that the phosphorus builds up at the surface of the soil if it's not incorporated. And so it doesn't take really a PhD to figure out that if you're not incorporating it, you're going to start to get more coming off in a dissolved form. But again, I want to mention this partly in the fact that tools of management, that there's some sort of common sense applied, because when you talk to Pete Richards and Dave Baker, these were the recommendations that were basically came up with. You need to incorporate manure and fertilizer. That's again a no-brainer. Really try and get it into the surface if you can. Put it on in the spring. Don't fall apply because it's sitting there on fallow ground, so you can put cover crops on. And so these are the recommendations. And when they came out with those, what happened was the reality actually is when we heard it yesterday, when we heard the farmers, we've got these tools, but sometimes we miss that quote of it being practical, and well, it just falls down through the cracks, and to a certain extent. Farming, as most of you, is very time intensive. There's a lot of things that have to be done, especially in the spring, and they maybe have 1 or 2 days of window to either till, to apply pesticides, herbicides to plant. There's a strict. Now, if you don't have a couple of days window there to which to apply that fertilizer, you're lost, you're shot. And so, if you were a farmer wanting to minimize your risk, you make sure you got it on in the fall if you get an opportunity. The fertilizer actually usually costs less in the fall than it does in the spring, so you buy it in the fall like we would go to the supermarket and buy food. So there are all these other drivers out there, once we get this research and these tools, that make some of the tools we develop less effective. Another one was soil compaction. The consultants came back and said, it's better if we put it on a frozen ground, because if it's wet and we have to get it out there, we're going to rut the soil, it's going to damage that soil surface, we're going to lead to more erosion, you're going to lead to more nutrient loss. And so I guess the point here, it ain't simple, and there isn't no one solution, and hopefully our tools will be able to address this cautionary note here, this tale, of there being these other other things that are out there operating, and that we don't lose sight of the reality of what farming is doing and when we're using and developing our tools. And so to conclude, I think we've all realized these tools needed to be validated, if you want to call it that, or assessed, or compared with field runoff or model data. The revision of the 590 or the indexes need to define a point above which no P can apply. Several of those states didn't do that, and that was no fault of theirs. There wasn't an incentive, or there wasn't it wasn't on their radar when they did it. I had a call from a guy in one of the states asking for some information to help develop his index, and I said, when do you need the information? Well, I've got to do it this week. They were kind of basically given it a week, or he had allowed himself a week to develop the index for that state. And so it was just a priority for different states, and that's not criticizing that state, it just wasn't that priority at that time, and things have changed. But we need to define a point above which no P can be applied, and that's one of the revisions that are going through. I think this revision will allow us to look at where there are inadequacies, how we can address them, and to get some equivalency across state lines. We had the same problem with soil testing. Farmers only a few miles away in different states come up with different recommendations. It doesn't improve our probably limited credibility to start with when they see that. And that's going to be a challenge. And then this other idea of quantitative and predictive, and I'm just going to end there and leave that hanging maybe for the after break as to, obviously I'm a supporter of, well, qualitative, get it right, but I'm not saying that quantitative don't have some benefits. And, in terms of it being quantitative, it does allow you to assess a state to say, yes, it's working or not working. And so, we've got to somehow decide there are some pitfalls in having it quantitative, and you have a number. That's then easily to say that's a loss limit, and then we start to transition into using these tools, which are kind of extension tools for farmer management of phosphorus, to becoming a model of predicting very small amounts of phosphorus coming off. And we're kind of sliding into this comfort zone, and I'm not sure whether we really need to be, and I'm not saying that quantitative models can't, but we probably need to be thinking about whether we do need separate tools, and that one tool for phosphorus management isn't going to do everything that we think we need to be doing. And so with that, I will start and allow you time to get some coffee. Is there any questions? We do have time for